In our previous lessons, we learned how to find the vertical asymptote, the horizontal asymptote, the holes in the graph, all of the attributes of the graph. Now the final part of the lesson is to put them on the graph. This is example number 1 in your green notes, ISN 11-3. At the top of your notes, you have a chart with all of the information we previously figured out, and now we're going to put it on the graph. There isn't a hole to put on this graph. I'm going to put my vertical asymptote at x equals -2. You're going to put that in with a dotted line. I'm going to put my horizontal asymptote in at y equals 1/3. That looks like that would be about a half. So less would be 1/3. I intercept at 2, 0. I have my y-intercept at 0, -1/3. If I want to make a little bit more accurate graph, I could come in here and calculate another point on my graph. That's what the table is. So I could figure out f -4. And so that would be, nothing canceled out in this graph, so that would be x minus 2 over 3x 6, plug in a -4. -4 minus 2 over 3 times -4 plus 6. Okay, that's going to be a -8 on top over -6. I could also calculate f of -1. Okay, so that's going to be -1 minus 2, 3 times -1 plus 6. That's going to be a 3 on the bottom and a -3 on the top. And so that's going to be -1. So in your XY table, -4 is going to go with -1.33. -1 is going to go with -1. And so that gives you a couple more points to figure out on your graph. Now, graph. One, 2, 3, 4, and -1 1/3. That didn't look right. And -1 and -1. Let me check the sign on that problem. The negatives would cancel out. That's why it didn't look right. So this point over here would be about right there. And so to get those points, I picked one, I went just a little bit to the left and the right of this asymptote. So this graph is going to curve like this and down like this. By putting in a few extra points, it just makes the graph more accurate. Example number 2. For example number 2, the first thing I see in the chart is I have a hole. I have a hole at -1, +1. A hole is indicated by an open circle. I have a vertical asymptote at x equals 3. That's indicated with a dotted line. I have a horizontal asymptote at y equals 2. I have an x-intercept. I have a y-intercept at 2/3. So this part of the graph is going to go like that. Instead of filling in that chart that I have on your paper, I'm going to fill in the rest of the graph by stage. And down 3, this is going to go over 1 and up 3. If this goes over 1, 1, 2, 3, down 2, 1, 2, 3, up 2, but it's not going to be full on this side of the graph. And so this is a relatively good sketch of what that graph is going to look like. This is example 3 in your notes. I believe I may have said the wrong number. Example number 4 in your notes. Example number 4 in your notes has a hole at 1, 2, 3, 4, 5, 6, 7. Holes are indicated by an open circle. And so it doesn't have any asymptotes. It has an x-intercept. It has a y-intercept at 1, 2, 3, 4. You could figure out some additional points on that line. The equation after you cancel it out is f of x equals x plus 4. So if you put in a 3, 3 plus 4 equals 7, that represents the point 1, 2, 3, 1. If you put in the point 5, 5 plus 4 is equal to 9, that may go off my graph. Oh, there it is right there. And so you can see that these points are lining up in a straight line. Should be a straight line, not a crooked line. So you're going to complete your graphs after you figure out the holes, the vertical asymptote, the horizontal asymptote. You will notice in your assignment today it's set up in a little bit different format, but all of the same information is calculated.